What if right now, in this exact moment, another version of you is making a completely different choice? Not in some distant galaxy, but here, just beyond the fabric of our reality. The idea of parallel universes isn't just science fiction, it's a theory backed by some of the brightest minds in physics, suggesting there could be infinite versions of our world, each with its own twists and turns. Today, we're stepping through the looking glass to explore 25 of the most astonishing parallel universes that might exist alongside ours. From worlds where gravity works in reverse to realities where history unfolded in ways you'd never believe, these possibilities will challenge everything you think you know about existence. Buckle up, this journey is about to bend your mind. Ever opened a door and wondered what would have happened if you'd chosen the other one? That's where our first parallel universe comes into play, the quantum multiverse. According to quantum mechanics, every tiny decision you make, from flipping a coin to choosing what to eat for breakfast, doesn't just create a single outcome, it splits reality into multiple paths. Picture this: at the quantum level, particles exist in a haze of possibility called superposition, meaning they're in multiple states at once until observed. Schrödinger's famous cat thought experiment illustrates this perfectly. In one universe, the cat is alive, and in another, it's not. Both realities exist simultaneously until the box is opened, forcing one outcome into existence. But here's where things get wild. What if that branching doesn't stop at particles or cats? What if every possible outcome of every possible choice spins off into its own fully realized universe? That's the heart of the quantum multiverse. Somewhere right now, another version of you took that job offer you turned down, or boarded a different flight, or even chose a different breakfast cereal, and their world unfolded in ways you'll never see. The implications are staggering. Infinite versions of reality, all coexisting just beyond our perception, each shaped by the smallest twists of chance. So the next time you hesitate between two choices, remember, you might not just be deciding your future, but creating an entirely new universe. But what if reality isn't just branching like a tree? What if entire new universes are constantly bubbling into existence, each a self-contained cosmos with its own rules? That's the mind-bending premise behind the bubble universe theory. Picture the early moments after the Big Bang, a fleeting fraction of a second when space itself expanded faster than light, a process called cosmic inflation. Physicist Alan Guth proposed that this explosive stretching of spacetime didn't just happen once. It could be ongoing, eternally spawning new universes like bubbles in a boiling pot. Here's how it works. When a patch of space undergoes inflation, it pinches off into its own isolated realm, carrying its own version of physics. Some of these bubbles might have stronger gravity or slower light. Others could have forces we've never imagined. And just like soap bubbles floating in air, these universes might drift apart forever, or occasionally brush against each other, leaving ghostly imprints in the cosmic microwave background. The unsettling beauty of this idea: we're stuck inside our own bubble, forever cut off from these alien realities. So while we puzzle over why our universe has exactly the right conditions for life, there could be countless others out there where the laws of physics make stars impossible, or where reality behaves in ways so bizarre our brains couldn't begin to comprehend them. Now, let's stretch our imagination even further into the hidden dimensions of the string theory landscape. Forget just one or two parallel worlds. String theory suggests there could be 10 to the power of 500 possible universes, each with its own unique structure. That's a 1 followed by 500 zeros, a number so vast it dwarfs every atom in our observable universe. At the heart of this idea lies the concept of tiny, vibrating strings, the fundamental building blocks of everything. But here's the twist: these strings don't just dance in the 3 dimensions we know. They vibrate through 6 or 7 additional dimensions, curled up into intricate shapes called Calabi-Yau manifolds. Think of these like the hidden folds in an origami masterpiece too small for us to see, yet dictating the very laws of reality. Depending on how these dimensions twist and compact, they could produce universes where gravity is weaker, where time flows backward, or where matter behaves in ways we've never seen. Some theorists even propose that dark matter, the mysterious substance holding galaxies together, might just be ordinary matter trapped in one of these hidden dimensions, forever out of reach. The unsettling truth: we may be floating in a cosmic ocean of possibilities, stuck in just one version of reality while countless others hum silently beyond our perception. So the next time you feel like the universe is vast, remember, it might be infinitely vaster than you ever imagined. What if everything you see, touch, and experience, every star, every mountain, even your own hands, is nothing more than an incredibly detailed illusion? That's the startling idea behind the holographic universe. Imagine our entire three-dimensional reality isn't the whole story, but just a projection, like a movie playing on the surface of an unseen two-dimensional screen. This isn't science fiction, it's a serious theory proposed by physicists like Leonard Susskind, born from an unlikely place, the mysteries of black holes. Here's the puzzle that started it all. When an object falls into a black hole, all its information, its atoms, its structure, its very essence, seems to vanish forever. But quantum mechanics says information can never truly be destroyed. So where does it go? Susskind and others realized the answer might be written on the black hole's event horizon, the point of no return. Every bit of information about the swallowed object could be encoded on this two-dimensional surface, like data etched onto a cosmic hard drive. Now take that idea and stretch it to the entire universe. What if our 3D reality is just a hologram, with all the information needed to build it stored on some distant two-dimensional boundary we can't see? That means every tree, every galaxy, even your thoughts, might just be shadows cast by information vibrating on the edge of existence. The strangest part: this isn't just philosophy, it's math. Physicists have found that equations describing events in a 3D space can perfectly match those written for a 2D surface. So if reality is a hologram, it's one with flawless mathematical consistency. Whether we're truly living in a projected illusion or not, one thing's certain: the universe is far stranger than it appears. What if everything around us, the stars, the oceans, even your own heartbeat, were lines of code in an unfathomably complex simulation? This isn't the plot of a sci-fi movie, it's the simulation hypothesis, a startling theory suggesting our reality might be an artificial construct, like an ultra-advanced video game created by a civilization far beyond our own. Philosopher Nick Bostrom laid out a chilling trilemma. Either advanced civilizations never reach the capability to simulate universes, they choose not to, or most unsettlingly, we're almost certainly living in one right now. Think about it: if a species could create simulations indistinguishable from reality, and they ran countless iterations, the odds tilt heavily toward us being inside one rather than the original. Elon Musk famously put it bluntly: the chance we're in base reality, about 1 in billions. But how would we even know? Some theorists speculate about tiny glitches, moments when the fabric of reality seems to stutter, like déjà vu or sudden déjà rêve, where familiar places feel eerily scripted. Others wonder if quantum indeterminacy, the way particles behave unpredictably until observed, might just be processing limits, like a cosmic computer conserving resources. And what about the so-called programmer gods? If this is a simulation, whoever built it could be unknowable entities tweaking variables behind the scenes, or even indifferent engineers who have long forgotten their experiment running in some vast digital archive. Whether this idea terrifies or fascinates you, one thing's clear: if true, it would rewrite not just science but the very meaning of existence. So the next time your phone glitches or you catch the clock freezing for a split second, ask yourself, was that just a coincidence or a fleeting glimpse behind the curtain? Imagine a hidden world made of ghostly matter, identical to ours in every way, yet perfectly inverted. This isn't science fiction. It's the mirror matter universe, a parallel reality where particles carry opposite charges, spinning backward through time while obeying the same fundamental laws. The concept springs from CPT symmetry, a cornerstone of quantum physics stating that if you flip a particle's charge, mirror its position, and reverse time's arrow, physics should still hold true. Now picture an entire cosmos where this symmetry plays out on a cosmic scale. Stars, planets, even life forms, all built from this elusive, antimatter counterpart to our familiar atoms. But here's the twist: while mirror matter would share gravity with our universe, it'd barely interact with light or ordinary matter. That means you could pass right through a mirror planet without a whisper of resistance, its gravity the only hint of its presence. Some scientists suspect dark matter, the invisible glue holding galaxies together, might actually be evidence of this shadow universe tugging on ours from just beyond perception. The implications are dizzying. Civilizations could thrive in the same space as us, completely unaware of our existence, their light forever out of reach. Even time itself might flow differently there. What we perceive as forward, they could experience in reverse. So next time you notice something oddly out of place, a glimmer where there shouldn't be one, or a gravitational tug from seemingly empty space, ask yourself, could it be a fleeting glimpse of our silent cosmic twin? What if the Big Bang wasn't the beginning but just another chapter in an endless cosmic cycle? This is the breathtaking vision of the cyclic universe, a model where existence isn't a one-time event but an infinite loop of rebirth. Physicist Roger Penrose proposed a radical twist on cosmology. Instead of our universe expanding into nothingness, it might eventually reset itself, giving rise to a brand new cosmos from the ashes of the old. Here's how it works. As our universe expands over trillions of years, galaxies drift apart, stars burn out, and even black holes, the last holdouts of structure, slowly evaporate through Hawking radiation. Eventually, space becomes a vast, empty sea of stray particles and dim energy. But Penrose saw something profound in this bleak fate. At this point, time itself loses meaning. There's no matter left to measure its passage. And in that timeless void, the universe's geometry subtly resets, becoming mathematically identical to the conditions just before the Big Bang. Like a cosmic phoenix, a new eon bursts forth, starting the cycle all over again. The eerie beauty of this theory, it suggests our universe might carry faint echoes of its predecessors. Penrose and his team claim to have spotted concentric rings in the cosmic microwave background, potential imprints of colliding supermassive black holes from a previous cycle. If true, these ghostly patterns would be like cosmic fingerprints, proof we're just one iteration in an endless chain of universes, each inheriting subtle traces of the last. So the next time you gaze at the night sky, consider this. The same stars overhead might have shone countless times before, in universes long forgotten, and will blaze again in futures we'll never see, a never-ending dance of creation and dissolution stretching across eternity. Step away from the idea of branching timelines and consider something even more radical, a universe where every possible outcome isn't just hypothetical but physically real. That's the many worlds interpretation, physicist Hugh Everett's bold answer to one of quantum mechanics' greatest puzzles. While the Copenhagen interpretation suggests particles exist in a blur of probabilities until observed collapsing into a single state, Everett's math paints a far wilder picture. In his version, there's no collapse. Every possible outcome plays out, each in its own fully realized universe. Picture rolling a die. According to Copenhagen, it lands on one number and the other possibilities vanish. But Many Worlds says all 6 outcomes happen, each spawning a new reality where that result becomes fact. This isn't just about dice or particles, though. Every flicker of quantum uncertainty, every choice, every chance event splits the cosmos anew. Somewhere, Napoleon won at Waterloo. elsewhere, dinosaurs never went extinct. And in countless realms, versions of you are living lives shaped by decisions you never made. The theory takes an even stranger turn with quantum immortality, a thought experiment where consciousness seemingly cheats death. Imagine a scenario where you face a fatal quantum event, like a gun triggered by radioactive decay. In most universes, the gun fires, but in an ever-dwindling fraction, it doesn't. From your perspective, you'd only experience the realities where you survive, creating the illusion of invincibility. Of course, this isn't immortality as we dream of it, just a bizarre consequence of infinite divergence. Critics argue this interpretation feels wasteful, conjuring endless universes to avoid the oddities of quantum collapse. Yet for others, it's elegant in its simplicity. No special rules for observation, no privileged collapse moment. Just an ever-expanding tapestry of reality where every story gets told. Whether it's true or not, one thing's certain. If ever it was right, the cosmos is far more crowded and far more fascinating than we ever imagined. Picture floating alone in an endless, pitch-black void, no stars, no planets, just infinite nothingness stretching in all directions. Then, against all odds, atoms randomly assemble into a fully formed, conscious brain. No body, no senses, just a solitary mind hallucinating an entire universe into existence. This disturbing thought experiment isn't horror fiction, it's the Boltzmann brain paradox, a cosmic riddle born from the laws of thermodynamics. Here's the unsettling logic behind it. In an infinite universe governed by entropy, the tendency toward disorder, even the most improbable events must happen eventually. Given enough time, random particle fluctuations could spontaneously create anything. A chair, a planet, or even a self-aware mind conjuring false memories of a world that never existed. Statistically, these Boltzmann brains should vastly outnumber real, evolved observers like us. So why do we experience a coherent, stable reality instead of floating as lone phantoms in the dark? Some physicists argue this paradox exposes flaws in our understanding of cosmology. Maybe the universe isn't infinite, or entropy behaves differently than we thought. Others propose we're living in a simulation cheaper to code than a universe full of real brains. The most haunting interpretation: we could be Boltzmann brains right now, hallucinating this conversation, our memories, even the laws of physics, just a fleeting mirage in the void. Of course, most scientists dismiss this as a statistical absurdity, but the fact that thermodynamics even allows the possibility shakes the foundations of what we call real. So the next time you're certain of something, the warmth of sunlight, the sound of a loved one's voice, ask yourself, are you truly here or just a momentary flicker of order in an endless sea of chaos? What if our entire universe is just a single sheet of reality, drifting like a cosmic leaf through unseen dimensions? This is the startling vision of the brain multiverse, a theory where everything we know exists on a vast membrane or brain, floating in a higher dimensional space. Picture a piece of paper floating in a room. That paper is our 3D universe, unaware of the room's true depth. Now imagine other sheets drifting nearby, each hosting its own complete cosmos with different laws of physics. The theory emerges from string theory's most mind-bending implications. In this model, the Big Bang wasn't a spontaneous eruption from nothing. It could have been a violent collision between our brain and another, unleashing the energy that birthed stars, galaxies, and eventually us. These collisions might not be one-time events either. Cyclic brain interactions could spawn endless new universes, each with its own unique conditions. Even stranger, gravity might be the only force leaking between these dimensions. That would explain why it's astronomically weaker than other fundamental forces. It's not confined to our brain like light or matter. Some physicists speculate that dark matter's mysterious pull could actually be gravity from objects in a parallel brain, subtly tugging at our universe from beyond the dimensional veil. The implications are staggering. Entire civilizations could thrive on neighboring brains, utterly invisible yet closer than we think. And if another collision looms in our cosmic future, it might not just reshape reality, it could rewrite it entirely, birthing a new cosmos from the wreckage of the old. So the next time you gaze at the night sky, remember, the universe might be far thinner and far stranger than it appears. Somewhere in the vast cosmic tapestry, there might exist a realm where time doesn't march forward, it spirals. Imagine waking up each morning to relive your life in perfect detail. Every laugh, every heartbreak, every choice replaying exactly as before. This is the time loop universe, a reality where existence isn't linear but an endless cycle, like a record stuck on repeat. Philosopher Friedrich Nietzsche called it eternal recurrence, the idea that every moment, down to the smallest atom's vibration, will recur infinitely. But here's where physics catches up to philosophy. Einstein's general relativity allows for closed time-like curves, loops in spacetime where an object could theoretically return to its own past. Under extreme conditions, like near a spinning black hole, these loops could stitch time into a circle, trapping events in an unbreakable rhythm. Would each cycle play out identically, or could tiny variations creep in like a cosmic game of telephone? Some theories suggest quantum randomness might introduce subtle changes. Your coffee tastes slightly different one loop, a stranger smiles at you the next, until eventually the universe diverges entirely into a new timeline. Others argue the loop is rigid, every particle locked into its ordained path forever. The chilling implication: if true, you've already lived this exact moment countless times before and will again, with no memory of the repetition. Yet there's a strange comfort in the thought. If time is cyclical, then loss is temporary. Every sunset, every farewell is just an intermission before the universe hits replay. Nietzsche posed the ultimate test. If told you'd relive your life endlessly, would you despair or rejoice? Your answer might reveal more about reality than any equation ever could. So the next time déjà vu washes over you, ask yourself, is it just a glitch in memory or an echo from a loop you've already lived 1,000 times? What if every star, every atom, every thought you've ever had wasn't just described by math but actually was math? That's the radical proposition of the mathematical universe, a realm where numbers don't merely model reality, they construct it. Physicist Max Tegmark takes this idea even further, suggesting that all possible mathematical structures exist as physical worlds in a level Roman form multiverse. In other words, if an equation can describe a universe, that universe is out there, humming along in some cosmic library of realities. At first glance, this might sound abstract, but consider how deeply math is already woven into existence. The golden ratio appears in seashells and galaxies. Pi's infinite digits seem encoded in the curves of rivers and orbits. Even the chaotic flutter of a butterfly's wings follows mathematical chaos theory. Tegmark's argument: these aren't just patterns we've discovered, they're the scaffolding of reality itself, now stretch that idea to its wildest limits. Universes governed by entirely different equations might lurk beyond ours. Some could have 4 fundamental forces instead of 3, or spatial dimensions that warp in ways our brains can't visualize. Imagine a cosmos where circles don't follow pi, where 2 plus 2 doesn't equal 4, not because the math is wrong, but because their math defines a different kind of logic. The haunting question this raises: if consciousness emerges from mathematical relationships, could self-aware beings exist in these alien numberscapes? A civilization might perceive time as a fractal or gravity as a probability gradient, their entire experience untranslatable to ours. Yet in Tegmark's view, their reality is just as valid, another page in the infinite textbook of mathematical possibility. So the next time you solve an equation or glance at a clock, pause. Those numbers might not just be tools, they could be the very fabric of universes you'll never see, whispering that existence is far more than matter and energy. It's a grand, silent symphony of pure mathematics playing out in endless variations. At the moment of the Big Bang, something extraordinary may have happened. The universe didn't just explode into existence, it split in two. While our cosmos expanded forward in time, another was born in perfect mirror image, the anti-universe, a realm where time runs backward and antimatter reigns supreme. This isn't just speculation, it's a serious hypothesis rooted in CPT symmetry, a fundamental rule of quantum physics. The idea is simple yet staggering. If you take our universe and flip its charge, mirror its spatial coordinates, and reverse the flow of time, the laws of physics should hold true. So why couldn't an entire reality operate under those inverted conditions? Picture a world where stars burn with anti-hydrogen, where rivers of positrons flow instead of electrons, and where every event unfolds in reverse. A cup shatters on the floor, then leaps back into someone's hand perfectly intact. Rain rises into clouds, people grow younger, their memories fading into the future rather than the past. Yet here's the twist: to observers living in that universe, none of this would feel strange. Just as we perceive time moving inexorably forward, their brains, wired by causality's arrow, would experience their version of normal. The eerie part: if we could somehow peer into this mirror cosmos, we'd appear just as bizarre to them, aging unnaturally, entropy flowing the wrong way. This theory could solve one of physics' biggest mysteries: why antimatter is so vanishingly rare in our universe. The answer: it's not rare at all. It's simply concentrated in the anti-universe, balancing the cosmic scales. Some researchers even suggest the two realms could be invisibly entangled, separated only by the Big Bang's initial conditions. If true, the implications are profound. Every decision we make here might ripple backward into their past, or forward, depending on your perspective. So next time you watch smoke curl upward or an ice cube melt, remember, somewhere in a universe unseen, those processes are running in reverse, and to someone there, we're the ones living life upside down. What if reality itself is awake, not just containing consciousness, but being consciousness? The conscious universe theory turns our understanding inside out, proposing that awareness isn't just a product of brains, but a fundamental feature of existence like gravity or light. This isn't mysticism, it's a serious scientific debate with roots in quantum mechanics' strangest quirk, the observer effect. Take the famous double-slit experiment, where particles behave as waves until measured, then suddenly choose a definite state. Some interpretations suggest this collapse happens because of observation, implying consciousness plays an active role in shaping reality. But what if it's not just human minds doing the observing? Philosophers and physicists flirting with panpsychism argue that even atoms might possess faint glimmers of experience, like a universe-wide hum of subjectivity. Now stretch that idea to cosmic scales. Could entire galaxies, or even the universe itself, develop a collective awareness? Imagine black holes as neural nodes in a vast cosmic brain, gravitational waves as its thoughts rippling across space-time. The universe might not just contain life, it is life evolving toward some unimaginable form of self-knowledge. Critics dismiss this as poetic speculation, but the math holds surprises. Integrated information theory, for instance, quantifies consciousness as a property of any system with sufficient complexity, meaning a star or a supercomputer might possess some form of inner experience. Even if the universe isn't alive now, could it awaken someday, like a dormant mind finally opening its eyes? Whether you find this idea or inspiring or unsettling, one thing's clear: if consciousness truly shapes reality, then every glance at the night sky isn't just observation, it's participation in an ancient, unfinished conversation between the cosmos and itself. Deep within the structure of reality, patterns might repeat themselves across scales we can barely comprehend. This is the essence of the fractal universe, a cosmos where every galaxy, every atom, even the vast emptiness between stars, mirrors a grand design that stretches infinitely inward and outward. Picture a snowflake under a microscope, intricate, self-similar patterns repeating no matter how far you zoom in. Now imagine that same principle governing the entire fabric of existence. The idea takes inspiration from mathematician Benoit Mandelbrot's fractal shapes that maintain their complexity at any magnification. Coastlines, mountain ranges, even the branching of trees follow this endless repetition. But what if the universe itself obeys the same rule? Our observable cosmos, with its swirling galaxies and cosmic voids, might just be one tiny iteration in an infinite nesting of realities. Zoom out, and our entire universe could be a single speck in a supercosmos, part of a pattern so vast it defies comprehension. Some theories even suggest black holes could be bridges between these layers, each singularity birthing a new universe inside, creating an endless cascade of realities within realities. If true, we might not just be living in a universe, but inside an immeasurable fractal, where the same fundamental structures repeat across scales we'll never perceive. The beauty of this idea, it blurs the line between the infinitely large and the infinitesimally small. The dance of electrons around an atom's nucleus might mirror the orbits of planets around stars, not just metaphorically, but as part of the same unbroken pattern. So next time you trace the veins of a leaf or gaze at a spiral galaxy, remember, you might be glimpsing a fragment of a design that has no beginning, no end, and no edge, just an eternal echo of itself. Imagine a universe where the very fabric of reality is being ripped apart not by some cataclysmic event, but by an invisible, unstoppable force lurking in the void itself. This is the phantom universe, a realm where dark energy doesn't just nudge the cosmos apart, it consumes it. While our universe faces a slow, cold demise known as the Big Freeze, this parallel reality offers a far more terrifying fate, the Big Rip. Here's how it unfolds. Dark energy, the mysterious force speeding up our universe's expansion, behaves differently in this phantom realm. Instead of maintaining a steady push, it grows stronger over time, like a runaway engine with no off switch. First, galaxies are torn from one another, vanishing over horizons of darkness. Then, stars within those galaxies are ripped away, leaving lone suns adrift in an endless black. But the horror doesn't stop there. Planets are shredded from their orbits, then atoms themselves are wrenched apart. Protons and electrons torn asunder by the stretching of spacetime itself. The final moments, a silent, empty universe where not even light can escape the accelerating expansion. Time and space lose all meaning as reality dissolves into a sea of disconnected particles, each unable to interact with the others. A cosmic graveyard where nothing can ever touch, collide, or exist together again. What makes this scenario so chilling isn't just the violence of the end. It's the loneliness. In our universe, even the Big Freeze leaves matter intact, drifting in an icy but shared darkness. The phantom universe offers no such comfort. It's a slow-motion erasure of all connection, where the last thought in the last conscious mind would be the crushing realization that nothing, and no one, will ever be seen again. So the next time you hear about dark energy's grip on our cosmos, remember, the forces shaping our fate could have been far, far worse. Somewhere out there, in the multiverse's infinite library of possibilities, such a nightmare might already be unfolding, a universe where existence itself is a candle in the wind, flickering against an unstoppable storm. Imagine the ultimate cosmic Russian nesting doll, a universe hidden within a black hole, which itself sits inside another universe, and so on, ad infinitum. This is the mind-bending premise of the black hole universe theory, where these gravitational behemoths aren't just destroyers of stars, they're creators of entire realities. The idea stems from a startling property of black holes. At their cores, Einstein's equations break down and space-time stretches into infinite density, a singularity. But what if that singularity doesn't mark the end of physics? What if it's the spark of something entirely new? physicist Lee Smolin took this idea even further with his theory of cosmological natural selection. Picture black holes as cosmic seeds, each birthing a baby universe inside with slightly tweaked physical laws. Just as biological mutations drive evolution on Earth, Smolin suggests universes might evolve too, with black holes acting as the mechanism. Universes that produce more black holes would, in turn, spawn more offspring, while those less efficient at creating them would fade into cosmic obscurity. Over countless generations, this could explain why our universe seems so finely tuned for black hole production, and for life itself. The implications are staggering. If true, our entire cosmos might be the descendant of an ancestral universe's black hole, its laws of physics honed by eons of trial and error. Somewhere inside the supermassive black hole at the center of our Milky Way, an entirely new universe could be unfolding, one where gravity is stronger, light moves faster, or even where time flows backward. And just as we emerged from a singularity, so too might an infinite chain of universes stretch both behind and ahead of us, each a unique experiment in the laws of reality. For all their terrifying reputations, black holes might not be cosmic dead ends, they could be portals to beginnings we can scarcely imagine. So the next time you hear about one of these dark giants lurking in space, remember, it might not just be consuming matter, it could be nurturing an entire cosmos in its depths waiting to be born. Hidden in the equations of particle physics lies a tantalizing possibility, a universe where every known particle has a secret twin, a mirror image balancing the cosmic scales with perfect symmetry. Welcome to the supersymmetric universe, a realm where electrons have selectron partners, quarks pair with squarks, and even photons dance with photinos in an elegant subatomic waltz. This isn't just mathematical fantasy. It's the core prediction of supersymmetry, or SUSY, a theory so compelling that physicists have spent decades hunting for traces of these shadowy superparticles in our own reality. In this parallel cosmos, the symmetry between matter and force-carrying particles isn't just beautiful, it's transformative. Here, the delicate balance of particle interactions could solve mysteries that haunt our universe. Dark matter, for instance, might simply be the lightest superpartner, lingering unseen yet shaping galaxies with its gravitational whisper. Even the vacuum of space could hum with different energy, preventing the slow fade into heat death that awaits our own future. But where this universe truly dazzles is in its longevity. While ours faces an inevitable cold demise as energy scatters into the infinite void, supersymmetry offers a cheat code. With superparticles constantly decaying and regenerating, energy might recycle eternally, like a cosmic fountain of youth. Stars could reignite from the ashes of their own collapse, and black holes might shed their mass into new particles, stitching the fabric of reality back together before it unravels entirely. The bittersweet truth, if supersymmetry exists in our cosmos, its effects are tragically subtle, so well hidden that even the Large Hadron Collider has yet to find definitive proof. But in some other universe, out there among the infinite possibilities, these ghostly twins might be the rule, not the exception. A place where every particle we know is half of a grander equation, and where the universe's end isn't an expiration date, just the quiet turn of an endless symmetrical dance. While most universes dance to gravity's slow, steady rhythm, one reality hums to a very different tune, where crackling electromagnetic forces reign supreme. This is the plasma universe, a cosmic storm of charged particles sculpting stars, planets, and perhaps even life itself into existence through sheer electric might. Picture a cosmos where gravity is just a background whisper, and instead, searing filaments of ionized gas plasmas stretch across the void like celestial lightning, weaving structures grander than any galaxy. The visionary behind this idea, Nobel laureate Hans Alfvén, saw something profound in plasmas, their ability to self-organize. In our universe, lightning forks caustically, but in a plasma-dominated realm, those jagged paths could twist into vast, stable circuits, channeling energy across light years. Stars might form not from collapsing dust clouds, but where these cosmic currents pinch together, igniting under electromagnetic pressures we can barely fathom. And life, in such a world, biology could take forms stranger than fiction. Imagine organisms built not from carbon chains but from charged dust grains, their bodies shaped by magnetic fields. Complex structures might arise in the turbulent gaps between plasma streams, living currents feeding off the universe's boundless electric hum. Even intelligence could emerge, not as firing neurons, but as patterns resonating through glowing filaments, thoughts flickering like auroras in a star's corona. The eerie part, our own universe, might hold glimpses of this alternate reality. Plasma makes up 99% of visible matter, from the solar wind to interstellar nebulae. Perhaps in some distant corner of the multiverse, Alfvén's vision isn't just theory, but the reigning order where the night sky doesn't twinkle with stars but crackles with eternal living light. So the next time you see a bolt of lightning or the rippling glow of neon, consider this. In another reality, those fleeting sparks could be the very threads weaving the fabric of existence. Amid the swirling theories of cosmic beginnings and fiery explosions, there's one universe that defies them all, a realm without birth, without death, where existence simply is. This is the steady-state universe, a bold alternative to the Big Bang, where space stretches endlessly and matter materializes out of nothingness to keep the cosmos eternally balanced. The idea was born in the 1940s when astronomer Fred Hoyle dismissed the notion of a singular explosive origin. Instead, he envisioned a universe in perfect equilibrium, expanding, yes, but continuously replenishing itself with new atoms appearing in the void. Picture a river flowing steadily, its waters renewed by unseen springs so it never runs dry. In this universe, galaxies drift apart over eons, but fresh hydrogen atoms bubble into existence to fill the gaps, weaving new stars and worlds into the cosmic tapestry. What if, somewhere in the multiverse, Hoyle's vision wasn't discarded but proven true? A reality where time has no starting gun, no looming heat death, just an unbroken, unchanging dance of creation and expansion. No fiery singularity, no fading embers of a dying cosmos, just perpetual renewal. For life in such a universe, the implications would be profound. Civilizations could rise and fall in endless cycles, never facing the despair of an inevitable end. The night sky wouldn't whisper of a violent past or a fading future. It would hum with constancy, a promise that the universe has always been and always will be. Critics called Hoyle's model flawed when cosmic microwave evidence pointed to a Big Bang, but in a parallel reality, perhaps the clues aligned differently. Maybe there, the cosmos truly is ageless, its galaxies glowing with the quiet confidence of eternity. No explosions, no contractions, just the gentle, undying heartbeat of a universe that refuses to end. What if the universe isn't just a collection of stars and galaxies, but a living, breathing entity? The living universe theory takes the concept of Gaia, Earth, as a single organism and scales it up to cosmic proportions. Imagine the cosmos not as a cold, empty void, but as a vast, interconnected being where black holes pulse like cellular mitochondria, galactic filaments act as neural pathways, and dark matter flows like a cosmic circulatory system. This idea isn't just poetic speculation. Some physicists suggest that the universe's fine-tuned constants, the precise balance allowing atoms, stars, and life itself, might hint at something deeper. A self-regulating system, adjusting and evolving like a biological organism. Stars could be its energy sources, supernova its recycling mechanisms, and the expansion of space itself, its slow, deliberate growth. Now take this a step further. If universes are alive, could they interact? A meta-ecosystem of cosmic beings, some competing for resources, others forming symbiotic relationships. Picture universes exchanging energy through black hole bridges or older realities, seeding younger ones with the conditions for life like cosmic pollination. The terrifying alternative, a Darwinian struggle where universes devour each other, with only the fittest surviving to reproduce through new Big Bangs. Whether you see this as metaphor or literal possibility, the implications are staggering. If our universe is alive, does it think, does it want, or is it simply an unfathomable pattern, cycling through existence like a heartbeat echoing across infinity? One thing's certain, the night sky suddenly feels less like a static backdrop and more like the shimmering skin of something vast, mysterious, and awake. What if everything around us, the chair you're sitting on, the screen in front of you, even the sensation of your own breath, isn't real, not in the philosophical sense, but as a literal collective hallucination? This is the chilling premise of the illusory universe, a reality where existence might be nothing more than an elaborate trick of perception. Ancient Hindu philosophy called it Maya, the cosmic illusion veiling true reality. Modern skeptics frame it as the brain in a vat paradox. What if your consciousness is just a floating mind, fed artificial sensations by some unfathomable machine? Think of reality like a virtual reality headset, but one you can never take off. Every sight, sound, and emotion could be carefully crafted signals, a flawless simulation indistinguishable from truth. Even science hints at this unsettling possibility. Neuroscientists know our brains don't experience the world directly, they construct it. Light becomes color, vibrations become sound, all filtered through the quirks of biology. Now imagine that process hijacked, your senses puppeteered to show a world that doesn't exist. The line between illusion and reality grows thinner every year. Advanced VR already tricks our brains into feeling present in digital spaces. AI can generate faces, voices, even memories of events that never happened. If technology keeps advancing, could we one day engineer entire shared hallucinations so convincing they replace the real world entirely? Here's the twist. Even if we're living in an illusion, it might not matter. If the chair feels solid, if love feels real, if the stars still inspire awe, does the distinction hold weight? Or is reality, by definition, simply what we collectively agree to experience? The illusory universe forces us to confront not just the nature of existence, but the fragility of our grip on it. So the next time you reach for your phone or sip your coffee, pause. That familiar weight in your hand, that bitter taste on your tongue, are they truly there or just echoes in a cosmic dream? Deep within the quantum fabric of reality, every tiny entanglement between particles might be stitching together the very pixels of existence itself. This upgraded vision of the holographic universe, let's call it 2.0, doesn't just suggest reality is a projection. It reveals how the cosmos could be encoding itself in ways that push the boundaries of information itself. Think of two entangled particles as cosmic twins. Change one, and the other instantly responds, no matter the distance. Now imagine this phenomenon writ large, with countless particles acting like interconnected pixels on a vast, unseen screen. Every interaction, every flicker of energy could be updating the grand projection we call reality. The catch, just like an image on your phone, there's a limit to how much detail can fit in a given space. Physicists calculate a maximum density for information in any volume, roughly 1 bit per Planck area, the smallest meaningful unit of space. This cosmic data cap has startling implications for parallel realities. If the universe really is a hologram, there might only be so much storage available across dimensions. Some theories suggest this could constrain the number of possible alternate worlds, not infinite, but a staggering yet finite library of variations. Picture a cosmic hard drive running simulations, each reality competing for bandwidth. Some might be crisp and vivid, others low-resolution echoes where details blur at the edges. But here's the twist: entanglement doesn't just store information, it processes it. Like a quantum computer, the universe could be performing calculations at every level, rendering reality in real time. Black holes, with their event horizons etched with perfect information, might be the ultimate proof, nature's way of showing us the projector behind the screen. So next time you feel déjà vu or notice an eerie symmetry in nature, consider this. You might not just be living in a hologram, but a dynamic, ever-optimizing one, where every choice you make is a new line of code in a cosmic program far grander than we'll ever fully grasp. Among the infinite possibilities of parallel realities, there exists a universe where entire stars become tools not just for energy, but for computation on a scale so vast it defies imagination. This is the Dyson Sphere universe, a realm where civilizations have ascended beyond planets, beyond solar systems, to harness the very power of suns for purposes we can barely fathom. Picture a colossal structure surrounding a star, capturing every photon of its light. This is the classic Dyson Sphere, theorized by physicist Freeman Dyson. But in this parallel reality, such constructs aren't just power plants. They're cosmic supercomputers known as Matryoshka brains. Layer upon layer of computing infrastructure orbits the star, each level running simulations so detailed they might as well be universes themselves. Here's where the line between creator and creation blurs. If a civilization could simulate consciousness, entire histories, minds, and societies, then who's to say our own universe isn't nested inside one of these simulations? The unsettling thought isn't just that we might be someone's experiment, but that we could be part of an endless chain, simulations within simulations, stretching back to some unknowable prime reality. And the ambition doesn't stop there. A Kardashev-type Roman III civilization, having mastered galactic-scale engineering, might not stop at one star. They could encircle entire clusters, weaving a network of Matryoshka brains into a computational tapestry vast enough to model every possible permutation of existence. The ultimate goal: to answer questions beyond mortal comprehension, the origins of reality, the nature of time, or the existence of deeper layers beneath their own. Yet there's a haunting counterpoint. If such civilizations exist either in our future or another branch of reality, why haven't we detected them? Perhaps they operate in dimensions beyond our perception, or maybe their simulations are so flawless that even the question of reality becomes irrelevant. One thing's certain: in a Dyson Sphere universe, the night sky wouldn't just sparkle with stars. It might glow with the quiet hum of countless superminds, each pondering the same cosmic riddle we are just from the other side of the screen. So the next time you stare at the stars, consider this. They might not just be balls of burning gas, but the processing cores of realities beyond our own, running on the borrowed energy of an unfathomable intelligence. And somewhere, in some distant layer of existence, another version of you could be gazing up, wondering the exact same thing. Now let's push the boundaries even further, into a realm where every theory we've explored doesn't just coexist but intertwines, layering realities upon realities in an endless cosmic tapestry. This isn't just a multiverse, it's the ultimate ensemble, a staggering meta-reality where all possible universes, quantum branches, bubble dimensions, holograms, simulations, and beyond stack like pages in an infinite book. Picture this: each layer operates by its own rules, from the bizarre time loops of cyclic universes to the electric storms of plasma realms. But here's the twist: they might not exist in isolation. Some theories suggest a hidden scaffolding, a meta-law governing how these realities interact. Think of it like the operating system behind a vast cosmic computer, where one universe's black hole births another's Big Bang, or where entangled particles bridge dimensions we can't perceive. The hierarchies could be mind-bending. Perhaps our entire multiverse is just one tiny node in a grander network, where higher dimensional beings perceive our branching timelines as static threads in their version of space-time. Or maybe there's a Darwinian struggle playing out, universes competing, merging, or even consuming one another, with the fittest laws of physics surviving to shape the next layer of existence. And what about consciousness in this ultimate ensemble? If every possible version of reality exists, then somewhere, a universe might have cracked the code beings who have mapped the meta-laws, navigating the multiverse like sailors charting oceans. Could they peer into our reality, or are we, too, just nested within someone else's experiment? The beauty and terror of this idea, it renders the very concept of everything quaint. Reality isn't a single canvas, it's a fractal of canvases, each painted with different brushes, different rules, yet all somehow connected. So when you gaze at the stars tonight, remember, you might not just be looking into space, but through it into the echoes of countless other worlds, each a reflection, a variation, or perhaps a key to understanding the deepest mystery of all, what lies beyond the ultimate ensemble. From quantum branches splitting with every tiny choice to time-looping realities where history endlessly repeats, we've ventured through 25 breathtaking universes, each stretching the limits of what we thought possible. Some whisper of hidden dimensions curled tighter than atoms, while others roar with the fury of plasma storms on cosmic scales. There are realities where time runs backward, where black holes birth new worlds, and where the very fabric of existence might be nothing more than a flawless illusion. What makes these theories so electrifying isn't just their strangeness, it's how they force us to question everything. If parallel worlds bubble into existence beyond our sight, does that make our choices more meaningful or less? If the universe is awake, observing itself through us, does that deepen our purpose or dissolve it into stardust? Every possibility we've explored today, from holograms to simulated superminds, doesn't just expand the cosmos, it redefines our place within it. So here's the real mystery. Which of these universes resonates with you? Does the idea of eternal cycles comfort you, or does the holographic theory send your mind spinning? Drop your thoughts in the comments. Let's debate which reality feels most alive, most plausible, or simply most thrilling to imagine. And if you're hungry for more cosmic wonders, hit that subscribe button. The multiverse is vast, and we're just getting started. Until next time, keep looking up and remember, reality might be stranger than any of us dare to dream.